It's episode 54 of the Digitalization Tech Talks podcast, and your tech duo, Jonas Narinder and Don Mack, are back in the studio. Before diving into today's topic, however, we'd like to celebrate that our podcast has been ranked 7th on Million Podcasts' top 100 list of most influential Industry 4.0 podcasts of 2025. And this is a great honor for us and really shows our continued focus on telling compelling stories about digital technologies through the eyes of our guests that join us from a lot of different industries, and those stories resonate with our listeners. So a big shout out and thank you to Million Podcasts for this ranking. And of course, also thank you to all of our listeners that tune in every last Thursday of the month to listen to our podcast. And of course, also to all of our guests that have been on in those now 53 plus episodes. We did include the link to Million Podcast post in the show notes, so go check that out if you want to see more details. With that, let's move on to today's episode, where we'll be diving deep into the silicon heart of innovation, the semiconductor fabs. These aren't your average factories. We're talking about some of the most complex, high-stakes environment in any manufacturing, where nanometers matter and precision is everything. We'll be exploring how digitalization is reshaping the future of chip manufacturing. This is from AI-driven optimization to the promise of digital twins. We'll take a look at how semiconductor companies are not just keeping up, but future-proofing their fabs for what's next. We'll also chat about the real-world challenges of digital transformation, how to set meaningful goals in a sea of data, and what it takes to turn cutting-edge design into physical chips. So a lot of content to cover. With this episode focusing on insights from the semiconductor industry, we're also moving into uncharted territory for this podcast. What's your take on that, Don?
Yeah, as you mentioned, we have talked to a number of different industries. Some of the ones that come to mind are chemical, pharmaceutical, metals and mining. There are many others as well. And this will be particularly interesting with this first time delving into the semiconductor industry. In fact, I think you could even say it's fabulous. Sorry about that. I did have to mix in a dad joke in honor of the recent Father's Day holiday, and I apologize for that. So I'm particularly interested to see how many similarities and differences there are with other industries we've covered due to the uniqueness of the semiconductor manufacturing process.
With that, let's introduce today's guest. We're excited to welcome a global expert in the world of manufacturing automation and digital transformation, Attila Lengyel. With over 2 decades of experience spanning Hungary, Japan, and the United States, Attila brings a rare blend of cultural fluency, a lot of technical depth, and strategic vision. He holds a PhD in system science from Kobe and Tokyo universities, and his career has taken him from cutting-edge research labs in Japan to leading digital transformation initiatives at Intel as well as Western Digital. He's currently serving as Senior Director of Corporate Research at Intel's Foundry Automation team. And in this role, he is shaping the future of high-volume manufacturing by integrating emerging technologies into real-world operations. And that's the stuff we like to hear about. So we're really excited. He's also a prolific inventor with 9 patents, a published researcher, and a recognized leader in Industry 4.0 innovation, including projects spotlighted by the World Economic Forum. Quite the resume, Attila. It's really a pleasure to have you on this show.
All right, thank you very much for the kind introduction. It's really great to be here. I've been really lucky to work with some amazing places around the world and, be part of teams that are pushing the boundaries of how we make manufacturing smarter, faster, and more efficient. Personally too, I've been always very passionate about solving complex problems and, turning ideas into real-world impact. I am excited to share some of these experiences with you today, and I hopefully will spark a few new ideas along the way.
Thanks, Attila, and welcome from me as well. You mentioned smarter, faster, and more efficient, and that is a common theme in our series. So it'll be interesting to learn how you're accomplishing that. How about if we start with a look ahead? Why is it that Intel is focused on future-proofing its fabs, and what does that actually mean in practice?
Yeah, I want to start the answer with a really good quote from Arthur Rock. He was an early investor, venture capitalist in Intel. And he really stated that the cost of a semiconductor chip fabrication plant doubles every 4 years. So let's just look at it. In 2024, the cost of a greenfield fab is way above $20 billion. Of course, this observation is not as famous as our co-founder's Moore's Law, but it is really true. And if you do the math, that means that in 2028, we can expect fabs costing 40 billion. And by 2032, we're looking at an upward trend of $80 billion. In light of that, our leadership kicked off an effort to research how our factories should be designed and built to mitigate this trend. We named this initiative as Far Future Factories. And really, digitalization is the key theme in the initiative. And we are working with partners to assess not only, 2030 plus opportunities, but as well, it's really always very important, even if you think about the future, to focus on immediate cost savings as well. Let's do a few examples. For example, in our latest Intel Foundry Direct Connect event, we showcased Chip collaboration with Boston Dynamics. Chip is our autonomous robot, and it's just rooming our factories to make work in our operations smarter, safer, and more efficient. For example, it's really exciting and it's always good to see. And it's very futuristic when you see these robots roaming around our sub-fabs. And these robots can listen to pumps noise and actually can recognize if maintenance is needed. And as well can read analog measurements. And if it's really needed, can alert technicians. Or for example, are taking videos, and within the videos, we can use Gen AI searches to find certain inaccuracies in our operations. So it's a really great help, and it's really nice to see these robots working and helping our operations.
We're now taking a brief break from this episode to briefly talk about a semiconductor webpage that might be of interest for you. On this page, you will find videos, customer testimonials. We have information about predictive maintenance, FMCS, cybersecurity, all geared towards the semiconductor industry. So go find the link in the show notes as usual and go check out that website. That is really cool. I could see some exceptional uses for a robot like that in my house, but I don't think it's going to make like the most appealing business case to get one of those into our home. But it would be kind of cool. So when getting Intel ready for the future, Attila, how do you go about setting goals related to implementing some of these digital technologies like the robot as an example? And more importantly, how do you make sure that these goals are being reached or attained?
Yeah, that's a really good question. And before I go into details, let me just add another quote here. Carl Sagan famously said that we are not predicting the future. We are creating it with every step we take. With that in mind, what's important that we are focusing on the future we will need to build, and we're not trying to predict what will happen. So it's a really important distinctions that you really need to build the future. You are building the future. So it's important that you create a blueprint where we want to be, and we break it down into initiatives attempting to resolve challenges to get to the blueprint. A really good example is, I always use this when I explain this, the moon landing. And not really the landing itself, but the effort to make it happen. Can you imagine when Kennedy told America that in 1961, he envisions that NASA will take a man to the moon and land there, and that will all happen before 1970. I do believe that that time, many scientists called him crazy. There wasn't even a rocket to go that far, right? But then people start to brainstorm, people start to think about it, and an endless hypothesis that kick off thousands of research activities. And importantly, while you do research, there will be many more failures that accumulates knowledge. And by the end, it results in 1969, July 20, when actually the landing happened. And throughout these failures, so much technology has been developed that actually these many more things, they're still improving our life today. A good example, semiconductors. Think about semiconductors were really born through this statement. Of course, it's indirectly, but it sparked Intel as being an honorable mention among many more companies and technologies that were created through those innovation efforts. So what we think about it, that at Intel we envision the digital operation, and we are building it as we speak. This focuses on creating a digital ecosystem where our employees can co-create with AI solutions. So if I said an example with the moon landing, I think we could easily say something like, we want to create a product or a technology in collaboration with AI. Practical examples are also there. For example, we heavily use LLMs and we are integrating into our workflows, reporting, coding, testing, and releasing softwares.
So, Attila, that's an interesting tie-in to a good example with the moon landing. And the future can sometimes be a scary place, but I think it can be a lot less ominous when you're taking this proactive approach that you're using to make it happen. So, Attila, I'd like to move on next to talk a little bit about challenges. That's something we like to cover with our guests. Based on your experiences, what are the biggest challenges to a full digital transformation today?
All right, I just spent 4 days in Florida on a conference discussing this. So, do we have enough hours to cover this? Let me try it in just a few minutes. Really, just focusing on what I think I have not really heard particularly being pointed out. We could go on with data, culture, and other technical and business aspects, but those are very well discussed, and I think we should not repeat that. However, based on what I have seen in my career so far, the biggest challenge is system architecture. Transforming those very heavy monolithic architectures and closed platforms to modular open platforms. I think this is one of the most important challenge and difficulties that we have, because in manufacturing we don't like change. We don't want to what's works, don't try to fix it, right? This simply just cannot be done overnight. I do believe that we have to shift how we design and architect systems, and this is a big statement. I think not many realize how much work it is. This usually can be done in smaller steps. Of course, it's we can't really boil the ocean, especially manufacturing. So that is what really you see in any successful use cases. You first isolate a problem to be solved, design the solution, and optimize the business process around it. Then you go to the next, and you go to the next, and you go continue. A famous saying that I really like to say is, think big, start small, but scale fast. Can you imagine if this followed the same blueprints? So if you look at it, when we do all these particular projects, the most important that we have to have a guidance. We have to have a blueprint that we follow. And once we follow that, then we can scale. So scale, usually it's not really mentioned too deeply, but we can do small things. But if it's really hard to adopt and it's really hard to continue, then we do need to think that we didn't do a good job with the scaling. And of course, lots of the projects, and we end up with pilot hell. What if we had same modular parts that it's built? So we put a lot of homework into it. We think big, but when we start small and we create small use cases, we actually follow that big thinking and follow a blueprint. But that's rarely the case. I do believe that to fully digitally transform a business, one needs to start with this blueprint on a larger scale. Then try it out in small steps to make sure architecture and designs are aligned to the moonshot blueprint. That's really how I feel.
And I really like that you're saying that, Attila. It is also something that we are preaching, or at least talking about quite often on this podcast. You take smaller steps that get you where you need to go, but you make sure you always have that big idea, vision, North Star, blueprint, moonshot, whatever you want to call it. Always keeping that in mind. And with this, we will end part 1 of episode 54, Inside Intel, Digital Twins, AI, and the Future of Semiconductors. We will release part 2 1 week from now, so make sure to log back in so you can listen to the continued conversation with Attila Lengyel from Intel.